Good afternoon, children. Yesterday, we discussed synopsis, microbes in human welfare, and household products, industrial products completed. Then the brief information before going for discussing MCQs, those synopsis, let us see. Generally, these microbes in how many sectors they have been used here? Microbes in human welfare. How many sectors they have been used here? Household products. Household products. We discussed household products. Second one, industrial products. Industrial products. Third one, biogas production. Fourth one, sewage treatment. Sewage treatment. And fifth one, biocontrol agents. Biocontrol agents. And sixth one, biofertilizers. They can be used as biofertilizers like this. So microbes in human welfare. Microbes used in the production of household products, curd, cheese, dough, tempeh kettle, caddy drink. These were discussed yesterday class. Industrial products, antibiotics, alcohols, enzymes, organic acid, bioactive molecules. These are over. Biogas production. Biogas means here generally one concrete tank, 10 to 15 feet depth concrete tank was it has been digging. So this much concrete tank is there. It is called as the concrete digester. This is concrete digester. On this digester, one lid is there. This is the lid. But it is high. What the provision is there? There is an inlet. What is the provision? It is an inlet provision. One more provision is there. There is an outlet provision. This is the outlet. Now through this inlet, what has been introduced? Cow dung. This is a digester. This is the digester. Digester, concrete digester. By the digging of soil, then using concrete bricks, one concrete digester has been established or set up. Into this tank, what we are taking, cow dung we are taking. This is added with water. Cow dung is added with water. It is made as a slurry. This slurry is introduced into inlet. Through the inlet, it is coming into the digester. But in the cow dung, what is present? Cellulose is present. You are taking raw material. What is the raw material has been taken? Cow dung has been taken. In the cow dung, what is present? Cellulose is present. This cellulose, when it is introduced into the digester, by this using lid digester, it has been closed. Then here this cellulose, in the presence of methanogenic bacteria and in the presence of water, first it is undergoes to hydrolysis. Then this hydrolysis, what would be formed here? Simple organic molecules can be formed. Simple organic molecules. This is here by this digestion, hydrolysis of cellulose, simple organic acid can be formed. But this simple organic acid, next further going to this here digestion, breaking, then what would be there? Estrogenic acid. First one, hydrolysis. What is the step here? Hydrolysis. Second one, acetogenesis. What is the acetogenesis? The process of production of acetic acid that can be called as the acetogenesis. Now, acetic acid means what is the acetic acid? CH3COOH, acetic acid. Acetic acid undergoes to what state? Decarboxylation. Due to decarboxylation, what can be removed here? CO2 can be removed. Finally, what will come here? Methane gas will come. CO2 released, methane gas will come. So, biogas, this is generally in the rural area for supplying this gas here to prevent the deforestation. Normally, in the rural area, they can cut the trees using this firewood for the purpose of cooking. But due to this, what would be their forest area? It would be declined. So to protect the forest plants as well as here to save this year natural gas resources, because here it is non-renewable. In future, much more deficit scarcity happens in this natural gas. So in place of natural gas here, rural India, generally here, Khadi and Village Industry Commission and Indian Agriculture Research Institute. Government of India, what is this bodies here? KVIC, Khadi and Village Industry Commission and IARI, Indian Agriculture Research Institution. These two bodies, they have planned to establish this biogas plant. But by using the cow dung, here biogas can be produced. Cow dung has been taken, made into slurry, introduced into the digester. In digester, what process has been going on here? There is a hydrolysis, esteogenesis, methanogenesis. Finally, due to the methanogenesis, what can be released? Methane can be released, CO2 can be released, and little amount of hydrogen sulfide or hydrogen is also released. That negligible amount, generally it will up to maximum 5% is hydrogen or hydrogen sulfide released. Most of the case 60%, 60 to 30%. Here what has been there, methane is there. And next CO2, what would be there? 30% CO2, 5% hydrogen sulfide is there. Such gas here through this pipe it is taken outside. Now this gas is coming out. This gas, if you have to connect to the stove, if you can on this stove and you can fire it, then it will be light, used for the cooking purpose. Simply here, whatever the waste is there, that waste it is taken out. Whatever after processing, what the cow dung is taken, it is processed in the concrete digester. Afterwards, the waste is there. Waste has been taken. Such waste is used as a manure in the fields. Like that here, biogas here, KVIC, Khadi and Village Industry Commission, Indian Agriculture Research Institute here, they have given the plan to save this year, what is this year, natural gas, and to reduce the burden as well as to save the forest. In these several events here, for the welfare of man, by using this here cow dung, they plan to produce the biogas. So the process of production of gas from this here cow dung or otherwise Icornia plant, that can be called as the biogas. But in this biogas idea, a concrete tank 10 to 15 feet depth here in the underground position, concrete tank it would be digged and made a concrete digester. This is provision inlet and outlet. Through inlet here, cow dung is made as a slurry introduced into digester. In the digester, what would be there? Methanogenic bacteria. Why? Because the cow dung means bacteria is source. Methanogenic bacteria occurs in cow dung, because methanogenic bacteria living in the rumen of cattle. Along with this here cow dung, they can come out. So that the methanogenic bacteria under anaerobic condition, they can degrade the cellulose of cow dung, which results ultimately methane will release. Along with methane, CO2, hydrogen sulfide is also released. Such gas is taken and it is collected through pipes. Such pipe is connected to the stove, then we can use for cooking purpose or domestic needs. And next case, what is that? What the waste after processing, what the waste will be there, such waste is taken through outlet, and that waste also used for what purpose here? Manures. That is the biogas production. And next one, sewage treatment. What is the sewage treatment here? This is here pollution. To prevent the pollution, sewage treatment is there. Here in the sewage treatment means untreated sewage and treated sewage. Due to the domestic activities, industrial activities, the municipal wastewater has been formed. This what is the sewage? Municipal wastewater. This municipal wastewater, normally it can be called as the sewage. This municipal wastewater, it can be called as sewage. But in sewage, what is there? Water is there. Then solid waste will be there. Next one, organic waste is there. Solid waste is there. Organic waste is there. And to make this here water, here this is a impure water. In impure water, what the waste is of this? Solid waste is organic waste. Here now this is a sewage. But to become this here unpolluted water, what we have to remove? Solid wastes we can remove, organic wastes we can remove. From the sewage, if we remove the solid waste, next case we remove the organic waste, what water will come? Impure water. This is a impure water to what would be the unpolluted water or polluted water too. This is a polluted water. This is what is here unpolluted water. A non-harmful water will be formed. Such water it is released into rivers, any water body, nothing harm it is. Therefore, here for the treating of sewage, generally in India, Ganga action plan, Yamuna action plants were introduced to treat the sewage before releasing into water bodies. But in this sewage treatment, what they can establish here, sewage treatment plants. For the sewage it is collected, it should be goes to sewage treatment plant. But in the treatment plant, two categories will be there. Primary treatment is there, secondary treatment is there. Primary treatment, it will be called here sewage treatment. Primary treatment is called as the physical treatment. Secondary treatment is called as the biological treatment. In biological treatment, again, two types are there. What are the two types here? First one, aerobic treatment. Second one, anaerobic treatment is there. Here, this is a sewage. Sewage undergoes to first which treatment here? Physical treatment. This physical treatment, how it will be called here physical treatment? This is also called as the primary treatment. Physical treatment is called as the primary treatment. In this physical treatment, what has been removed here? Floating debris, grit, some solid wastes can be removed. But in this primary treatment, how it is done here? By means of a process. It includes physical treatment, includes here filtration. It includes filtration. Second one is the sedimentation. Filtration and sedimentation. By using the filters here, what the floating debris are there, those can be removed. And it is sending into one tank. In the tank, it would be settled. What the grit is there, grit comes down. Then the what would be there? The floating effluent is there. That can be called as the primary effluent. So here, first one, the sewage undergoes to physical treatment. Physical treatment includes the filtration and sedimentation. In the filtration, what the floating debris are there, those floating debris can be removed. After removing these floating debris, what the grit to pebbles are there, by means of sedimentation, grit to pebbles can be removed. And the remaining effluent of it will be called here primary effluent will be comes here. Primary effluent here. This primary effluent here, then where it is going here, generally primary effluent can form a primary sludge to primary effluent. This primary effluent, where it is going, undergoes to secondary treatment. Primary effluent, it undergoes to secondary treatment. But secondary treatment, it is held in two ways. What is the two ways here? Aerobic tank. That is the aerobic treatment. Another one, what is here? Anaerobic treatment. Aerobic treatment and anaerobic treatment. Secondary treatment, it is a, how it will be called secondary treatment. This is also called as the biological treatment. Because here microbes are used. Generally, first treatment is physical treatment, second treatment is secondary treatment. But here this primary treatment, it is also called physical treatment. In this physical treatment, what have been removed here? Floating debris, grit to pebbles have been removed from sewage. So in the sewage means to the water, any grit to pebbles, floating debris are added. Next one here, organic waste is added. It will become the sewage or polluted water. Now from the sewage here, these physical or solid wastes can be removed by means of filtration and sedimentation. The primary effluent will come. Such effluent is passed to where it is secondary treatment. Secondary treatment held in how many ways here? Aerobic treatment and anaerobic treatment. But this secondary treatment is called biological treatment. Why it is called biological treatment? Microbes are used. What are the microbes used here? Aerobic microbes, anaerobic microbes are used. First you see this here, aerobic, this is a primary effluent. In primary effluent, this is primary effluent. In primary effluent, what waste is there? Organic waste is there. But organic waste, who will digest this organic waste here? Bacteria. So here they have taken aerobic bacteria, as well as what would be the fungi, protozoans have been taken. But into this aerobic tank, what the provision is there? Oxygen supply is there. But on supplying of oxygen to aerobic tank, the aerobic bacteria, they are digesting the organic matter. So which results, what will be there here? When they are digesting the organic matter, what demand is raised here? Oxygen demand is raised. biochemical oxygen demand. Biochemical oxygen demand here. But which results what would be there here? You see, this is organic matter. Here, this organic matter, here on supplying oxygen, it is degraded. It is degraded. How it is degraded? By the oxidation activity of microbes. So the aerobic bacteria, by using the oxygen, they are oxidizing the organic matter, which results what would be there? The oxygen demand is raised. That is called biochemical oxygen demand. Gradually decreasing the organic matter, whatever the BOD comes down. Whenever more organic matter is there, BOD is more. But here BOD, this organic matter is decreasing. Whatever the BOD value comes down. Finally, BOD it will comes to less than 1. Then organic matter content what happens here less. Then this polluted water what happens? Unpolluted. But here what would be there? Aerobic bacteria is there. First solid waste is removing. Aerobic treatment what we are removing? Organic matter we are removing. Next what is this? What the microbes we are using? Microbes and water only there. Now this is this aerobic tank. What would be there here? This is what the here sludge has been formed after aerobic treatment. That is called activated sludge. Such activated sludge where it is sending anaerobic tank. Activated sludge is passed. But here in anaerobic digester, anaerobic bacteria is there. This anaerobic bacteria works on the microbes used in the aerobic tank. So these aerobic bacteria is digested by anaerobic bacteria, which results biogas is produced. Such gas is collected, used for domestic purpose. Then water will become unpolluted. Why? Because first physical wastage we are removing. Here aerobic treatment, organic wastage we are removing. Anaerobic treatment, what the aerobic bacteria is there, they are removing. Finally, anaerobes are there. They could not harmful. Why? When they are exposed to air, they would damage. So that water, unpolluted water, released into water body, then water bodies would be safe. So like these microbes, they are used in the sewage treatment. Microbes used in the biogas production. Microbes used in the household products production. Microbes used in the production of various industrial products. And microbes used as a biocontrol agents. Normally, what is the biocontrol agents here? You see, these are biocontrol agents. Here, this is a plant. This is a plant. On this plant, suppose this crop plant. This is a crop plant. This is attacked by insect. One insect is attacking this crop plant. But these insects is damaging the crop. If we save from the insect, crop is growing well. How can we save the plant from insect? We are spraying chemical. What is the chemical? Insecticide chemical. Insecticidal chemical we are using. To save the crop plant, we are spraying insecticidal chemical on insect. The plant is safe. Those remains retain in the soil, it will cause soil pollution. After rainfall, same remains enter water body, cause water pollution. Finally, they enter this year, man, they can threat to this, they are causing various problems in the different organs of the human body. Different ailments, kidney failure, kidney problem, lung problem, liver problem, different vital organs can be damaged by using these insecticidal chemicals and pesticidal chemicals. So now, what is the eco-friendly approach here? Instead of these insecticidal chemicals, now what we are using here, organisms. If biocontrol agents means here, whatever these organisms we are using to kill the insects, those can be called as the biocontrol agents. Some microbes are used, some organisms are used. You see this here, some organisms used as the biocontrol agents. Now you can see here what are the important biocontrol agents you see. Ladybird beetle. What is the biocontrol agent? This biocontrol agent is here ladybird beetle. Ladybird beetle. Ladybird beetle, what can kill this? It can kill aphids and save the plants. So that it is called biocontrol agent. There is no need of spraying insecticide, pesticide. If we leave the ladybird beetle on crop plant, it will kill the aphids, protect the plant. So the important biocontrol agent is ladybird beetle. The organisms are microbes which can use it to kill the insects and pests. Those are called as the biocontrol agent. They can protect the plant without utilization of insecticidal and pesticidal chemicals from the insects and pests. And the important biocontrol agent is ladybird beetle is one of the biocontrol agents. Save the plants from aphids. And another one, dragonflies. Dragonflies here, how they can protect the plants here from mosquitoes. Dragonflies, you see these mosquitoes. They can save the plant. They can kill mosquitoes, save the plant from mosquitoes. And now you see this another one, bee spores. You can use the Bt spores as biocontrol agent. If you spray this here Bt spores on the plant, then they are capable to release the cry protein. Such cry protein, what it is doing, killing the insects. Already you know in application of biotechnology. Bt spores release the cry protein when the insects are pests ingesting the plant juice. Along with the juice, what will come? Here, cry protein enter the insect gut. In the insect gut, at alkaline pH, cry protein is activated, killing the insect. Therefore, Bt spores can be used as a insecticidal spores. This is what is here biocontrol agent. Next one, what can be used as a biocontrol agents here? Ladybird beetle, dragon, flies, Bt spores, Trichoderma pallispora. Trichoderma, this is a Trichoderma root-borne pathogens. This is a fungi. It releases the cleotaxin chemical. This is a plant. In this plant, this is root system. This sphere is called rhizosphere. The area surrounding the root rhizosphere. Any microbe is there, bacteria, whatever pathogen is there. Along with here, trichoderma is there. This trichoderma releases a toxin. Such toxin, what it is doing? Killing bacteria. Now, whatever pathogen surrounding this root, then here the plant is protected from root-borne pathogen in the presence of trichoderma. Therefore, trichoderma, it is used as a root-borne pathogens. So, root-borne pathogen, trichoderma is there. And next one, what would be there? Nuclear polyhedroviruses, nuclear NPV. Nuclear polyhedroviruses here, NPV virus. But this is species specific. Suppose here you see trichoderma, you see Bt spore, there is no species specific. What the several insects comes under Diptera, Leptoptera, Coleoptera, these all kinds of insects, they can be killed by Bt spore. But now you can take nuclear polyhedrovirus. Suppose here all insects may not harmful. Some insects are useful also. Therefore, you see this is a plant. So on this plant, any insect is coming. Suppose this insect harmful, we should kill this. This insect harmful, we should kill this. But useful. If we spray Bt spore, all are killed. But it is not eco-friendly. Useful insects are also killed. But nuclear polyhedrovirus, we are using species specific. Suppose the specific insect is harmful to plant. That harmful insects only killed. Useful insects are saved. So to maintain biodiversity, what is the ideal biocontrol agents here? These are the NPV, nuclear polyhedrovirus. There are also granuloviruses. What is here? Granuloviruses. In granulovirus, the important species is NPV. Granuloviruses are NPV, nuclear polyhedroviruses are biocontrol agent, but they are species-specific biocontrol agent. They can kill only specific species only. So they can use it in integrated pest management program. In the IPM means integrated pest management program is nothing but here. This is a important program, eco-friendly program. In this only, what is eliminated? What would be eliminated? Unuseful aspects are eliminated. Useful aspects are protected. What the living things they are useful to biosphere and biodiversity, saving the biodiversity, they are protected. And unuseful and harmful are eliminated. Such management is IPM or Integrated Pest Management Program. So here to maintain the crops, in this maintenance, useful living things can be protected, harmful will be eliminated, that program IPM. So in granuloviruses or NPV virus, they have been used in the Integrated Pest Management Program. Like this here, these are the biocontrol agents. Next, biofertilizers. What is the biofertilizers you see? Here, fertilizer. Normally, several fertilizers here. What are the fertilizers to the plants here? Ammonia is the important fertilizer. Ammonia, urea, nitrogen, phosphorus, potassium, several minerals are there. These the important thing is the ammonia. Whatever chemical which can support the plant growth, such chemical is called as fertilizer. If microbes are used as a fertilizer, biofertilizer. This is a plant. Here for this, what we are supplying ammonia. Then the plant is growing well. So that this ammonia which will become fertilizer. The chemical which can support plant growth well, such chemical is called as the fertilizer. Biofertilizer means here we are not supplying ammonia. This is a plant. In what we are supplying microbes. This is a what is here microbe is there. Such microbe only what will take from atmosphere nitrogen. In this microbe body, nitrogen how it is converted ammonia. Now microbes supply ammonia to plant. We are not taking artificial ammonia, artificial urea. Artificial ammonia, artificial urea, we are spraying. Those remains retaining soil. They will goes to the water bodies on falling rain. But on rain falling, then it enter the ecosystem, ultimately reach man, impact this year human health. For healthy safety, what we are using here, biofertilizers. But what are the biofertilizers? Rhizobium, azotobacter, azospirillum, several bacteria are using. But they can fix nitrogen in free living mode and symbiotic mode. You know very well this is rhizobium. This is fixing this nitrogen. Nitrogen fixation means conversion of molecular nitrogen into ammonia is called as the nitrogen fixation. If it is symbiotic mode means two organisms are living each other, in which here both are benefited one to another. Bacteria can take nitrogen, convert ammonia, ammonia supply to plant. In turn, plants provide food to the bacteria. Therefore, mutually both are benefited. That is called symbiosis. One, you have to see this here, symbiote nitro biofertilizers here. These biofertilizers, they are supplying ammonia to the plant. Generally, you see in symbiotic mode, they can fix nitrogen or free living mode. Azotobacter, azospirillum, they are free living mode. And now you see rhizobium, symbiotic mode, and frankia, symbiotic mode. Rhizobium, it can fix nitrogen in symbiotic mode with legume plants. Frankia with ulnus plant, that is non-legume plant. Yeah, so frankia can fix nitrogen in symbiotic mode, but with non-legume, not legume plant. Rhizobium with legumes, frankia with non-legumes. Legume means green gram, Bengal gram. These are the legumes here. So here pulses, red gram, groundnut comes under the legumes. You see here one more thing is there, cyanobacteria. Cyanobacteria means they are also called blue-green algae. Nostoc, Anabina, Aslatoria, these are blue-green algae. But these blue-green algae also having capable, they can fix nitrogen in free living mode as well as symbiotic mode. Here, blue-green algae, they can fix nitrogen in free living mode and symbiotic mode. Both cases, they can fix the nitrogen. So here, those are also used as a biofertilizers. But in rice fields, the most important biofertilizers are cyanobacteria. The effective biofertilizers in rice field, what is the answer? Cyanobacteria. This is the synopsis of microbes in human welfare. Then on this synopsis here, then we can discuss the MCQs here, NEET question paper. The same paper, it has been posted in your respective WhatsApp groups, and check your WhatsApp groups here. You can solve this here. Now, one by one, we can discuss this. And one more biofertilizer, mycorrhiza is also there. Another biofertilizer, what is this here? Mycorrhiza is also biofertilizer. It can supply phosphorus here. Mycorrhiza means here fungi associated with the root system. These fungi can dissolve and breaking this here rocks, supply the phosphate to plant. In turn, plant can supply the food to the fungi. The association between roots of higher plants and fungal filament is called mycorrhiza. Mycorrhiza example for symbiosis. This mycorrhiza is also one of the best biofertilizer. Now let us discuss this question number 1. Select the mismatch. Rhodospirillum mycorrhiza, Anabina nitrogen fixer, Rhizobium alpha alpha, Frankia alnus. We need a mismatch here. Anabina nitrogen fixer correct. Rhodospirillum is mycorrhiza, Rhodospirillum bacteria. Anabina nitrogen fixer correct. Rhizobium can having association with alpha alpha legume only is also. Frankia alnus. So except the first one, remaining all are the correct. So we need mismatch. What is the mismatch here? One is A is mismatch. Answer A. You see, Rhodospirillum, they given mycorrhiza. Rhodospirillum not having mycorrhiza. Rhodospirillum is a bacteria. Mycorrhiza means fungi plus root system of plant. But Rhodospirillum is a bacteria. Rhodospirillum cannot form the mycorrhiza. So what is the mismatch? Option 1. Here A is the mismatch. So first answer is A. Second answer, which of the following in sewage treatment remove suspended solids? Here, you know that what is this here suspended solids? It is a secondary treatment, primary treatment, sludge treatment, tertiary treatment. Which treatment can remove this here suspended particles here? Second one. Secondary or primary or sludge or tertiary treatment. You know that here sewage treatment held in two ways, primary, secondary. Primary means what they can be removing here, floating debris, pebbles, grit can be removed. Secondary treatment, biological treatment, aerobic treatment, anaerobic treatment. In aerobic treatment, what has been removed? Organic waste. Given question, what is the question? Suspended solids. Solids, how they can be removed? Solids, primary treatment. So answer, what is the second one? A. And what is the second one? Primary treatment. B answer. Primary treatment can remove this here solid wastes. Which of the following is correctly matched for the product produced by them? Here they have given microbe and their products. But what has been given correctly, you can see. Here, Methanobacterium lactic acid. Correct Methanobacterium? Methanobacterium methane, not one here. Methanogenic bacterium. Penicillium notatum, acetic acid, penicillin antibiotic, not acetic acid. Saccharomyces ethanol. Correct? Yeast is used for ethanol production? Yes. Estobacter ester antibiotics wrong. So what is the correct one here? Saccharomyces cerevisiae. This is a yeast. It can produce the ethanol. Correct one. 4 options given. Mismatch option. Correct options. But we need a correct option. Where is the correct option? Saccharomyces cerevisiae produce the alcohol. This yeast is used in alcohol production. Correct one. So third one. What is the answer? C is the correct one. And next one you see. Fourth one. Match the columns 1 and 2. Select the correct option using the codes given below. Citric acid, cyclosporine, statin, butyric acid. You see this here, question number 4. Here, column 1 and column 2. There are the 2 columns are there. Column 1 and column 2. Column 1, A is the citric acid. And B, what is the B? You see cyclosporine A. Cyclosporine A. And C, what is the statins and butyric acid? C is the statins. And D, what is the D? Butyric acid. D is the butyric acid. And column 2, what is the column 2? One is here trichoderma. Column 2, what is the one? One is trichoderma. One is the trichoderma. And 2 you see Clostridium. 2 is the Clostridium. And 3 you see what is Aspergillus. Aspergillus. Monostosis. 4 is Monostosis. Purpureus here. So you see citric acid, cyclosporine, statin, butyric acid, trichoderma, Clostridium, Aspergillus, Monostosis. In citric acid production, what has been used here? Citric acid production, Aspergillus is used. So A is what is this here? 3. Cyclosporine A. What has been used in cyclosporine A production? Trichoderma parasicorum. B is 1. And next one is statin. In statin production, what can be used here? Statin production, Monostosis purpureus. C is 4. And next one, butyric acid production. What can be used? D 2. Clostridium botulinum, here metric acid production. So here what is this D2? But where this option A3, B1, C4, D2, which option it is given? A3, B1, C. What is the C here? C should be 4, D2. A3, B1, C4, D2. Where it will be the option? Second option. Second option means B na answer. So answer is B. Fourth one answer B. This given correct options where it is given in the second option given. Second option means B. So answer what it is here? B is the answer. And now you have to see micro product and application was given in the given table. So we have to find out the correct one. One more table, question number 5. The answer, citric acid, it is produced from Aspergillus cyclosporin A, immune suppressive agent produced by the Trichoderma polysporum. Statins, they are the inhibiting cholesterol synthesis. Here, yeast Monostosis purpureus produced butyric acid, Clostridium botulinum. So this option A3, B1, C4, D2. Here in the given options, second option or B option is correct. So this is answer. Question number 4B. Next, we go for question number 5. Question number 5. In this fifth question, micro product and application. You see there is a table is given, but in this table, what is given? Microbe is given. Next here, product is given. Next one, application is given. That means what is the use? That is the application. You see micro product application. Now you can see micro streptococcus. Option A, streptococcus. This is option B. What is option B? Here Clostridium botulinum. Clostridium botulinum. Clostridium botulinum. Option B. Option C. Here what is given? Trichoderma polysporum. Trichoderma polysporum. Option C. Trichoderma polysporum. Option D. What was given? Option D. Monostosis purpureus. Monostosis purpureus. Monostosis purpureus. Now product. Streptococcus streptokinase. Streptokinase is given. Products names they are given. And life is Clostridium. They are given life is. And cyclosporin A. It is given. Cyclosporin A product. And statins. Monostosis purpurea statins. Now you have to see lowering of blood cholesterol is given. Lowering of blood cholesterol. It is here stated. And immune suppressive drug. Cyclosporin immune suppressive drug. Immune suppressive drug. And this one we have to see removal of stains. Here Clostridium removal of stains. And now streptokinase removal of clots from blood vessels. Removal of clots from blood vessels. You have to say this here. What is asking here? Which of the following is wrongly matched? What is wrongly matched here? Table is given. From this table, we have to find out the wrong one. Here, streptococcus streptokinase product correct is this product function removal of blood vessels correct. Blood clots correct. Blood clots are removed from blood vessel. Clot buster. Streptokinase is called clot buster correct only. Clostridium botulinum lipase is product. No. What is the product of Clostridium botulinum? Butyric acid. So this is wrong. Remove the stains wrong. And Trichoderma polysporum produce cyclosporin A. Yes. It is used as an immune suppressive agent. Yes. So that this is correct. And Monostosis purpureus yeast. They can produce products statins correct. Yes. Statins usage lowering of cholesterol. Yes. So this is correct. But what statement we need here? Yes. A is correct, C is correct, D is correct. But what we need? Wrong statement. In fifth question, from the given microbes, products and their function, we can choose this here wrong one. What is the wrong one here? B is the wrong one. So here fifth answer, what is this here? B is the answer. Question number 5, B answer. and match the following list microbes and their importance. You have to see this here. They have given microbes and their importance. So you have to mismatch is given. We have to do the match the following. You can write this question number 6. Here, this is a sixth question. In the sixth question, what is this here? Match the Saccharomyces cerevisiae. Column 1, column 2. Match the following. Column 1 and column 2. Column 1, Saccharomyces cerevisiae. Saccharomyces. Here, cerevisiae. This is Saccharomyces cerevisiae. Next one, B, Monascus purpureus. A is Saccharomyces. B is Monascus purpureus. C, what is the C? Trichoderma polysporum. Trichoderma polysporum C. What is the D? The D is the Pu-Ii-Neet-Bacteria ceremony. Pu-Ii-Neet-Bacteria ceremony. Here, Pu-Ii-Neet-Bacteria ceremony. Like this is microbes. Now, column 2, production of immune suppressive agent. One is, what is the product here? Production of immune suppressive agent. Immune suppressive agent. Here, number 1, production of immune suppressive agent. Number 2, what is the 2 here? Ripen in Swiss cheese. Ripen in Swiss cheese. Here, ripening of Swiss cheese. Number 3, what is this here? Commercial production of ethanol. Commercial production of ethanol. Commercial production of ethanol, number 3. Number 4, what is the 4? Production of blood cholesterol lowering agent. Here, production of blood cholesterol. Production of blood cholesterol lowering agent. Blood cholesterol lowering agent. These are the here actions are given. Saccharomyces cerevisiae. What purpose using Saccharomyces cerevisiae? Alcohol production. So A is what is here 4. Saccharomyces cerevisiae is a yeast. This yeast what purpose? Alcohol production. Alcohol, where it is this alcohol production is there? 3. Commercial production of ethanol. A is a 3. Alcohol production. And Monascus purpureus. Monascus purpureus, what purpose using? Cheese. What type of cheese? 2 type of cheeses are there. Swiss cheese, Roquefort cheese. Roquefort cheese, Penicillium roquefort. Swiss cheese, Monascus purpureus. What is the B? B is a 2. Here, this is only. Trichoderma polysporum. What is the Trichoderma polysporum? Cyclosporin A, immune suppressive agent. So C, what is here? 1. The next, Pu-Ii-Neet-Bacteria ceremony. What is the use of Pu-Ii-Neet-Bacteria ceremony? This is B, Monascus purpureus. Yeast here. Monascus purpureus yeast. What can produce here? Monascus. Sorry. Monascus purpureus yeast. Yeast. This is what purpose using here? This is a statins. B is 4. And Trichoderma polysporum. What is this? Cyclosporin A. Cyclosporin A means C is 1. And Pu-Ii-Neet-Bacteria ripening of cheese. What is here? D is the 2. So you see A3, B4, C1, D2. Once you see here, Saccharomyces cerevisiae, this is a yeast. What purpose using? Alcohol production. Alcohol production, where it is there? 3 actions. Monascus purpureus. What is this Monascus purpureus? Yeast. What purpose using this yeast? Statin production. Statins, what purpose using? Cholesterol. Reduce the cholesterol. So B is what is that? 4. Trichoderma polysporum. Trichoderma, what purpose using? Cyclosporin A production. How it is used here? Immune suppressive agent. So Trichoderma C, what is this 1? The Pu-Ii-Neet-Bacteria ceremony. What is the Pu-Ii-Neet-Bacteria ceremony? Ripening of Swiss cheese. So D is what is the 2? A3, B4, C1, D2. Which option it is there? A4, A3, B4. A3, B4, C1, D2. Which option it is? C option. Option C, it will be there. A is 3, B is 4, C is 1, D is 2. A3, B4, C1, D2, option C. So sixth answer, what is here? C is the answer. So here, these are, we have to discuss remaining questions in next class here. 2-3 classes I can finish here. These microbes in human welfare. Remaining 2 classes. Synopsis I explained. Now this one objective questions here. So tomorrow remaining objectives we can solve. We will finish within 2 classes here. These microbes in human welfare. Later remaining chapters we can discuss. There is any doubts, you can send message to the WhatsApp, seek clarification. Okay, thank you one and all.